Okay, this is rational exponents. Interesting thing about rational exponents, the square root of 2, which you should at this point know is 2 to the 1 half, was first discovered, well, there's an old 4,000-year-old clay tablet from the ancient Babylonians that has the square root of 2 correct to 5 decimal places, which is kind of fairly amazing. So mathematicians have been working with roots and what's been later defined as rational exponents for hundreds of years. Okay, we know that the fourth root of 2 is 2 to the 1/4. The concept is they can be written in what's called equivalent forms. Writing roots as an exponent allows you to apply exponent rules that work with your roots. Sometimes it's easier, sometimes it's not. Okay, they're just different uses. You should be able to use both and go the easiest way through solving problems. Okay, so rational exponents. Evaluate this. 16 to the 1/4. With a calculator, it's very easy. You just come over, you do 16 to the power of 1 divided by 4, and you should get 2. Without a calculator, yes, you could do that. All the exponent rules that we've talked about recently still apply. So it asks us to do this one without a calculator, 27 to the 2/3. And converting the bottom of the exponent, or the bottom of the fraction, is the root. Now, I don't really feel like squaring 27. And there's this beautiful power with these exponents that I can do it second and pull it out of the root. Do it in whichever order I want. The cube root of 27 is 3, and then I'll square that and I get 9. And it's good to be able to do that by hand. Yes, you can use a calculator on the exams, but it's good to be able to do it by hand because it might be quicker. Or what's really important is you might have to do it with variables. That's where it just keeps coming up. Okay, so simplifying some of these with rational exponents. Simplify this. So those are multiplied inside. Can't believe they used an X for multiply. I'm going to combine the insides first because they're nice and easy to combine. 3 over 2, negative 1 over 2 is 1. 3 halves plus 1 half, I add those exponents. And then I take that to the third, x to the third. The next one, 32x to the 10th, y to the 5th, all to the 2/5. So I have to apply that 2/5 to everything. 10 times 2/5 over y to the 5 times 2/5. 32 to the 2/5 is the 5th root of 32 squared. 5th root of 32 is 2. Squared is 4. 10 times 2/5 is 20/5 or x to the 4th. 5 times 2/5 is y squared. Last example. Okay, again, I'm going to have to take everything here to the 3/4, just applying my exponent rules, which means I'm multiplying these. When I get to my x's and y's. So 16 to the 3/4, that's 4th root of 16 cubed. The 4th root of 16 is 2. 2 cubed is 8. Multiply my exponents, x to the 15/8. Okay, 81. Again, 4th root of 81 cubed. 4th root of 81 is 3. 3 cubed is 27. Multiply my exponents, 3/16. So my final answer is 8x to the 15/8 over 27y to the 3/16. That is the end of that.